Welcome back to another AP Pre-Calc video. Last video, we decided to start talking about the unit circle, looking at its coordinates, kind of how it relates to each quadrant, and things like that. If you need to understand the unit circle, please go watch that video and how we can kind of break it down and look at those things. This video today is more so going to be focused on identifying coordinates when you're given the angles, and that will help us lead into being able to evaluate specific trig functions. Whenever I am dealing with the unit circle, one thing I always do is I draw out quadrant 1 of the unit circle. I think this quadrant is important because if you memorize this one, the other quadrants just change the signs of things. So I like to always draw out this quadrant. 45 degrees, 30 degrees, 60 degrees, and we can start to fill in each part. Remember, 30 degrees is the same thing as pi sixths. Remember, our radians count down: pi sixths, pi fourths, pi thirds, pi halves. And then our coordinates. Remember, the x values count down inside the square root. So it goes 3, It goes 3, 2, 1 inside, and the y values are just the flipped of that. So instead of 3, 2, 1, it goes 1, 2, 3. And the starting point and the pi halves spot, both those should just be common sense based off our unit circle being 1 radian measurement. Okay? 0 or 2 pi. So now that I have this drawn out, we want to be able to identify the coordinates of the angle. Well, when I look at number 1, it is 5 pi 6. I know because of pi 6, its coordinate must look something like this. So maybe I just start by writing that part down. I know it's at least going to have square root 3 over 2 and 1/2. I just need to know, where does it end? What quadrant is this angle in, so that I can determine then what the signs are. Well, 5 pi 6, if I were to rotate all the way to here, that would give me pi. 5 pi divided by 6 is less than 1 pi, though, because 5 over 6 is less than 1. So that told me I did not quite get to 5 pi. I was slightly less than that. 5 is 1 less than 6, so I did not get all the way there. That means my angle for this one ended in quadrant 2. I started here, I went around to 5 pi 6, it ended in quadrant 2. So what that tells me then is, because I'm in quadrant 2, we know the x value is negative there, and I've identified the coordinate. Let's look at number 2. 5 pi fourths. 5 pi fourths now is slightly larger than 1 pi. Because it is greater than 1 pi, I know that my angle must go further than 180 degrees. This value of 5 is 1 larger than 4, so we know that it goes into quadrant 3. It does not go any further. This value is nowhere close to 2 pi, but it is slightly larger than 1 pi. Our angle must be in quadrant 3. I know that in quadrant 3, both of my values are negative. Now I can analyze our fraction a little bit more. The denominator of 4, pi over 4, tells me what my coordinate should look like, where it's root 2 over 2. All pi over 4s have the same coordinate. We just check the signs. Number 9, 7 pi halves. 7 divided by 2 is 3.5. That's bigger than a full rotation. So let's simplify this one. Let's make this one a little bit smaller instead. So I could subtract 2 pi, or in other words, 5 pi halves. Doing that subtraction, I get 3 pi halves. Remember, the pi halves are all of your x and y axes. This one would be 0 pi halves. This would be 1 pi halves. This would be 2 pi halves, or just pi. This last one here would be 3 pi halves. 3 pi halves is on the y-axis. We know that the unit circle has a radius of 1, where the value moved 1 unit down and did not move left or right at all. This is our angle here. From there, number 12, same idea. Let's see if we can analyze it. Notice the angle in this case is negative pi thirds. That means I'm going in the negative direction. This is just 1 unit on top though, so I have to be in the first quadrant. I go in that direction. So we're going to stay in quadrant 4 there. From there, this is pi thirds. Pi thirds, we know, has a coordinate of 1/2 comma root 3 over 2. But since I am in quadrant 4, the y value should be negative. That is how we can identify the coordinates using the unit circle and the parts that we have memorized. Now let's talk about evaluating them. There are 6 trig functions that you should have memorized. The 6 trig functions you should have memorized is sine of theta. Sine of theta, we know, is opposite over hypotenuse. However, when you're looking at the unit circle, your hypotenuse is just 1. So therefore, sine is just the opposite side. The opposite side, if I had a triangle to diagram that, is just the y value. Sine theta, you can think of as O over H, or for the unit circle purposes, it's just y. Cosine uses that same logic. It is adjacent over hypotenuse. The adjacent in the unit circle, though, is x. If we talk about cosine, we are just taking the x value. Tangent, we should have that one memorized. Opposite over adjacent. The opposite we said was y. The adjacent we said was x. So from there then, the 3 new trig functions that you may not have heard of are cosecant, secant, and cotangent. Oops. Each of these are just the reciprocals of the original 3 trig functions. Cosecant is the reciprocal of sine, meaning is it h over o, or 1 over y. Secant is just the reciprocal of cosine. So again, we could just flip the fraction for that one. That would give us our 1 over x for that. Cotangent is the reciprocal of tangent, which would be a over o, or x over y. Let's go ahead, let's look at some of these problems now to figure out how to evaluate. Sine of negative pi thirds. Find where that is in your unit circle. It is negative pi thirds. That's quadrant 4 there. It is pi thirds. We know pi thirds is always 1/2 comma root 3 over 2. Because we're in quadrant 4, it's negative root 3 over 2. Sine, we said, is opposite over hypotenuse, but because your hypotenuse has a length of 1, it is just the y value. The answer to this is negative root 3 over 2. Number 20 says find cosine 3 pi fourths. 3 pi fourths, that's slightly less than 4 pi fourths, which would be 1 pi. So that means I'm going to be in quadrant 2. Because it is pi fourths, we know it's root 2 over 2 for both the x and the y value. Since we are in quadrant 2, the x value is negative. Cosine, we know, given this information on the right, is just the x value. So in this case, we know the answer is negative root 2 over 2. Number 21, tangent 7 pi sixths. Okay, it's pi sixths. It's slightly more than 1 pi, but based off of 7 over 6. So I know that would get me in quadrant 4, where my coordinate in this case would be negative root 3 over 2 and negative 1/2. It's that coordinate because it's divided by 6 and we are in quadrant 3. Tangent we know is y over x though, so I can take negative 1/2, divide it by negative root 3 over 2. Once I have that fraction, you can copy dot flip if you need to do that to change it to multiplication. But if you have a fraction over a fraction and the denominators are the same, those immediately cancel. So I really have negative 1 over negative root 3, which is just 1 over root 3. In math, we don't like to have denominators that have a root in them, so we can rationalize it by multiplying by root 3 over root 3. 1 times root 3 on top is root 3. Root 3 times root 3, that's the same thing as root 3 squared, which would just be 3. Our answer to tangent 7 pi 6 is root 3 over 3. Secant, cosecant, let's look at both those real quick for 22 and 23. 22, graph it. 5 pi 6, that's slightly less than 1 pi. That means I am quadrant 2. We are in terms of pi 6, so we know our coordinate has to be this. Quadrant 2 tells me the x value is negative. Secant. Secant is the opposite, not the opposite, sorry, the reciprocal of cosine. So I need the reciprocal of the x value. The reciprocal of the x value would be negative 2 over root 3. But again, I need to rationalize that. In order to rationalize, I can multiply the root 3 top and bottom, giving us negative 2 root 3 over 3. Last problem then, number 23, 7 pi fourths. 7 over 4 is slightly less than 2, so I'm going to be in quadrant 4 here. It is pi fourths, so I know this is my coordinate. Quadrant 4 tells me the y is negative. From there, cosecant, we said that cosecant is the reciprocal of sine. The reciprocal of sine means I'm going to flip whatever the y value is. The y value in this case is negative 2 root 2. But again, you do need to rationalize. In this case, we get negative 2 root 2 all over 2, or just negative root 2 once you simplify. That is our video for today.